Let's find derivative of x cubed using first definition. First definition says limit x approaches a, f of x, which is x cubed, minus a cubed all over x minus a. F of x is just the x cubed. F of a is just plug in a, which is here. Now we need to factor the numerator because if we plug in the a here, we get undefined. Numerator factors as x squared plus xa plus a squared. Remember this formula. If you have a cubed minus b cubed, we have a minus b, a squared plus ab plus b squared. So this is how I got from here. As we can see, we can cancel this. We left with limit x approaches a, x squared plus xa plus a squared. Can I go ahead and let x to be a? It's approaching a. Plug in a here, plug in a here. We have a squared plus a times a plus a squared. We have 3a squared. Hence, derivative of this is using this first definition, we get 3a squared. Next, let's use second definition. It says limit h approaches 0. Let's write it down the formula first. Limit h approaches 0. This says, can you plug in a plus h to your function, which is a plus h, plug in here. We have a plus h cubed minus f of a. It says plug in a here, minus a cubed all over h. Again, we cannot plug in h to be 0 because we get undefined. We need to factor the numerator. So first, let's open this expression. Limit h approaches 0. A, so formula is right here. I wrote it down. I'll follow this formula to open this expression. A cubed plus 3a squared h plus 3ah squared plus h cubed. Then I have this, which is minus a cubed all over h. Limit h approaches 0. As you can see, this cancels with this, and I have in this term h, in this term, and in this term h. Let me factor out one of the h here. I have 3a squared plus 3ah plus h squared all over h. H cancels with h. Limit h approaches 0. 3a squared plus 3ah plus h squared. Can I go ahead and plug in h? Do I get undefined? No. If I plug in h here, this is 0. This is 0. 3a squared plus 3 times a 0 plus 0 squared. We have 3a squared. So as you can see, we got also for derivative of x cubed, we got 3a squared. So we can anytime use any of these two definitions. If you want to check if your answer is correct, we can always check third way, how to find the derivative without definition. Without definition, the fastest way will be of any polynomial. If you want to find derivative of any polynomial, you drop the 3, drop the power, subtract 1. So 3x, 3 minus 1, we have 3x squared. So now, in conclusion, we can see that if we use the derivative definition, first one, we get 3a squared. If you use second definition of derivative, we also get 3a squared. And if you use definition by any derivative of any polynomial, we drop the power, subtract 1, we also get same answer. Which way do you like?